Okay, good morning, everybody. I'm glad to be here, and I would like to thank the organizers for inviting me to present this talk at the conference. I'll talk about olive meal wastewater. Is it an environmental hazard or a plant nutrition substance? Or in other words, can we turn lemon into lemonade? What is olive meal wastewater? Olive meal wastewater is a liquid waste of three-phase olive mills, and usually we refer to it as an environmental pollutant, or at least a potential environmental pollutant. In most countries, the permitted solution is controlled spreading of OMW on the surface, mostly in olive orchards, and the permissible amounts range between 50 and 80 cubic meters per hectare. The objectives of the current research were to study the effect of controlled application, on one hand, on physical and chemical properties of the soil and on tree performance. We tested different aspects of the OMW application. You see there is a list, but my talk will concentrate on the concentrations of P and K in the soil, on tree vegetative growth, fruit and oil yield and oil quality, and on leaf and P and K concentrations. The experiment was carried out at the Gilat experiment station. You see the experimental setup, randomized blocks, 5 treatments in 5 replicates. We separated the plots from each other in order to avoid root penetration from one plot to the other, and also substance penetration from one plot to the other by inserting a vertical thick polyethylene sheet. And that was the experiment. The trees were planted in 2004. The cultivar was Lecino. And here is some information about the area. As I said, it's at the Gilat Research Center, planting density 3.5 by 7 meters. Soil is low organic matter content, about 0.2, 0.3%. And these are the precipitation patterns of the years of the research from 2011 to 2015-16. The average is 200 millimeters per year, and these dots indicate the timing of the application of OMW. You see we had rain before and rain after. This is how we applied. We applied the OMW manually, equally distributed from the tree line to the border between 2 plots. And here is the tillage that we did. We had 5 treatments, 0, no application, 50, 100, 150, and 100 plus tillage of cubic meters per hectare per year. The history of the orchard from 2004 to 2011, we had regular irrigation and fertilization. During the years of the experiment, we had no fertilization at all. We relied only on the OMW contribution, but irrigation was regular. Irrigation was by drip, 1 line per row. As I said, manual OMW application. Tillage usually 1 month after application, and soil sampling was carried out before and after each application. In addition, leaf sampling took place once a year in July. Now, this is the average composition of the OMW. So you see, this is the average, this is the standard deviation, and let's concentrate on the major constituents. So we see that we had a relatively low concentration of mineral nitrogen. We had a higher concentration, a much higher concentration of organic nitrogen. We had relatively high concentrations of P, of phosphorus, of mineral phosphorus, soluble phosphorus, and total phosphorus was higher because part of the phosphorus is in the organic substance, and we had very high concentrations of potassium in the olive mill wastewater. Now, in our work, in the current presentation, I will not refer to the nitrogen in the soil because of the high interference of organic nitrogen. And in fact, we do not really know what happens to the organic nitrogen. It undergoes mineralization. Part of it transforms into N2 and disappears into the atmosphere. And it's quite complex to monitor it. You will see that also it did not have any effect on the trees and when you see the results. So I will concentrate mostly on P and K. Now, before going to the results, let's see what is the potential contribution of OMW to soil N, P, and K. So if the recommended amounts are 150 kilograms per hectare per year of nitrogen, 30 P and 250 K, you see that when we consider the mineral nitrogen, the contribution from the OMW is very low compared to the recommended amount. When we consider the total nitrogen, it's quite high, but as I said, referring to the total nitrogen is quite complex. When we look at P, so we see that when we apply 50 cubic meters per hectare per year, which is the permissible amount in Israel, we provide more or less 1/3 of the amount of P required by the trees. If we refer to soluble, to mineral P, if we refer to total P, it's about 50%. When we refer to potassium, already at 50 cubic meters per hectare per year, we apply, in fact, the whole demand according to the recommendations of fertilization. Now, we monitored P concentrations along the time. You see, these are the dates, and these are the different treatments. And we see that after these are applications, and we see that after each application, there is an increase, and afterwards there is a decrease in P. And we see that we do identify differences between the treatments. This is the control where we applied nothing, and indeed P level did not change. But, and this is the highest amount, the red. And we see, in fact, we can see a general trend of increase in soil P concentration with fluctuations because after application, most of the P is still extractable. This is also P, still extractable, and before the following application, it's not there because probably because of fixation, although here you see it's already high. It is still high before application, but the general trend is that there is an increase in P concentration, and it follows the treatments quite nicely, and there are significant differences between soil P content between the treatments. We measured P concentrations only at the 0 to 30 centimeters layer. That's what we presented because at the 30 to 60 centimeter layer, there was no effect. When we move to potassium, we see that fluctuations are much stronger, and we see a similar trend regarding treatments, regarding with time, an increase in potassium in the soil. In potassium, we also follow the 30 to 60 centimeters layer, and we see that after a certain time, after about 2 years, we begin to see an effect also on the deeper soil layers. With potassium, we also estimated exchangeable potassium percentage in the soil, and we see that when we applied higher amounts, we had a higher percentage of potassium in the adsorbing complex. And we see that in the large amounts, it's already from the first year. And in the small amounts, it follows the years. This was done during 3 years. Tree performance was not affected, not vegetative, not yield. Oil quality was not affected by any of the treatments, nor negatively, neither positively, which is quite good. Now, when we monitor the leaf concentrations, we see that in nitrogen, in fact, the trees were depleted. This is more or less, these values are around the threshold value for nitrogen. And here we see that nitrogen values went down, which means that the contribution of OMW to tree nutrition regarding nitrogen was in fact nothing, was not significant at all. And we see that the trees were significantly more deficient in nitrogen compared to the beginning of the experiment. When it comes to phosphorus, we see that in the control we went down significantly from 0.1 to 0.08. And in the other treatments, we had the same level, more or less, which means that the trees could absorb phosphorus from the OMW. When we come to potassium, we see again that here the trees went down in potassium concentration significantly. And here in the treatments, the trees absorbed potassium from the OMW, and the concentration, leaf P concentration, did not go down. Now, we took it one step further, and we made an estimate of the economic value of OMW application, assuming that we apply 50 cubic meters per hectare per year. So this is the contribution regarding P2O5 and K2O. If you make the economic estimation, we see that in fact we can save about, if we apply 50 cubic meters per hectare per year, we can save about 500 euros per hectare in fertilizers, because in fact we can have to apply only a small part of the P, and we don't have to apply K at all. So if we come to the conclusions, the controlled application of OMW didn't have any effect on tree vegetative development, fruit yield, or oil quality, even at rates 3 times higher than the permitted dose. The contribution of OMW to tree nutrition, to end tree nutrition, was negligible. OMW contributed significantly to P and K nutrition. OMW application followed by soil tillage was not different from application without tillage. And this is important because most intensive orchards are non-tillage orchards. So OMW application can replace at least part of P and all of K fertilization in olive orchards when applied at the permissible levels of 50 cubic meters per hectare per year. Yet, due to potential hazards, controlled application is required, followed by monitoring of the relevant parameters like K, P, soil properties, and so on. The detailed findings of the research were published in this article, and the research was funded by the Merck Foundation. Thank you very much for your attention.